The following is a 10-minute presentation showing a model replica I built of the World Trade Center and the resulting damage from 9/11. The actual dimensions of this model are 57 inches tall by 8.5 inches wide, which gives a scale ratio of 1/3 of 1% the size of the actual buildings. All information used to build this model was gathered from the NIST report, chapters 1 and 6, and a PBS documentary showing the actual construction of these buildings. To be an educated American, one must understand how the World Trade Center was built using two immense steel superstructures and how the office floors straddled these gigantic structures. The detailed model on the left shows how these massive two superstructures were built, while the paint can model on the right will allow me to conduct two demonstrations using basic high school physics that will address the events on 9/11. Keep in mind, the only reason the paint cans are shorter is that their width is narrower, and thus to be a replica must be slightly shorter as well. The outer superstructure consisted of 236 vertical steel columns, which are represented here. While this model is built to scale as best as possible considering cost, this model still has 50% fewer of the densely packed vertical columns, and these model columns are 50% smaller in diameter than the actual replica should be. The inner superstructure consisted of 47 massive vertical steel columns that extended straight up, going from the granite base all the way to the top, which housed all the elevators and stairwells. This massive inner superstructure was arranged in the center of the building and actually took up 25% of each floor's total square footage. Straddling these two massive superstructures are the office floors. These floors were made by connecting the inner and outer superstructure with steel trusses, then welding and bolting steel sheets on top, and then pouring lightweight concrete on top of this. Ironically, this type of floor construction was designed to smother fires by hermetically sealing the floors above and below in order to limit oxygen for the fire. This is one of the reasons I feel so much black smoke was seen on 9/11. The fire was being smothered or oxygen starved. Now for the damage. First off, we can see that nothing below the 86th floor was damaged by fire or plane impact. The bottom part of the building and the strongest part of the building is not harmed at all and has always held up the top through any and all powerful winter storms. Second, we can see that some damage was done to the outer superstructure over floors 93 through 99 where the plane hit. According to the NIST report, only 35 out of the 236 vertical columns were damaged, or 15% of the total outer columns were damaged. Again, only on these few upper floors. In addition, all damage to these outer columns was located on one side of the building. The other three sides were not damaged at all. We can see that there was some minor damage done to the inner columns, according to the NIST report. 6 out of the 47 inner columns were destroyed, or 13% of the inner structure was damaged. Again, only on these few upper floors and nowhere else above or below. As we can see, there are 6 columns completely severed and 3 others heavily damaged from a total of 47 inner columns. Again, nothing below this was damaged and was as strong as the day it was built. 9/11 was a calm and sunny day. The only forces acting on the building was a brief plane impact resulting in some upper floor damage and the office fires for 90 minutes afterwards. Let us turn to the paint cans and test the two hypotheses. One, that lighter upper floors can collapse an entire steel building at free fall speeds, even though the upper floors have always been held up by the undamaged building below. 2. That office fires can melt or weaken steel, and again, make the lighter top of a building fall through the undamaged, stronger and thicker bottom portion of a steel building at free fall speeds. Let's demonstrate the first scenario. What happens to the bottom 85% of a building when the lightest top portion falls onto the remaining steel building? Keep in mind, the building always held up the weight of the top, so physically nothing has really changed. Uh-oh, looks like we have a problem here. Let's try this again. And again. Now let's go to the second scenario regarding jet fuel melting or weakening steel. However, here we run into a problem from the start, since jet fuel and office fires only burn at an estimated 550 degrees Fahrenheit, while steel needs over 2,400 degrees Fahrenheit to melt. Furthermore, according to the NIST report, the hottest the upper floor steel beams ever got was 500 degrees Fahrenheit. Here, I show a time-elapse video with over 3 hours of constant burning by jet fuel. Not the simple 10 minutes as occurred on 9/11, with 80 minutes of normal office fires afterwards. Keep in mind, according to the NIST report, all jet fuel was used up within 10 minutes anyway, with almost half used up in the initial fireball outside the building. Of special note, in 1945, a B-25 aircraft hit the 78th and 79th floors of the Empire State Building. This building withstood the plane impact and resulting fires, only to be reoccupied by employees the following week. Because of this, the Port Authority required that the World Trade Centers be able to withstand a Boeing 707 hitting the buildings at 600 miles per hour, the largest plane at the time, and ironically, the same size as the planes on 9/11.